Okay, good morning. We start our lecture and we continue speaking about chapter 9, second half of chapter 9, which is epidemiology concepts and methods. And to continue from the previous lecture, let me remind you that we were speaking during previous lectures about the role of epidemiology in the development of healthcare systems and in the management of public health difficulties and challenges. So, epidemiology describes, as a discipline, epidemiology describes variations in morbidity and in mortality in time and space, and epidemiology tries to identify the variables that may explain the variations, including inborn and environmental factors. Epidemiologists also are involved in risk assessments, and epidemiology consists of the descriptive part as of analytical part and is aimed at etiological research. Epidemiology at the same time is closely related with basic biological science, clinical specialties, statistics, social sciences. So you see that epidemiology is a discipline which is strongly connected with different branches of biomedical science. That's why we say that together with research and by statistics, epidemiology forms very crucial and central part of the understanding of mortality and morbidity in population. So the concepts which use epidemiology, they are usable and useful in addressing a broad area of problems, and methods which are applied by epidemiologists are fundamental in assessing the knowledge which is essential to clinical medicine and public health. When we speak about assessments, we take into consideration three main projects of public health, which is treatment, prevention, and education of society members. Okay, the three aims, the three main basic goals of epidemiological studies are: goal number one, describing disease occurrence and distribution of disease in population groups and development over time. This is so-called trend. Goal number two is identifying cause of disease, etiology. And last but not least, undertaking experiments to assess the effects of treatment or preventive efforts. These all three main goals are very evident and very demonstrable in today's pandemic situation, when on the one hand we are describing the distribution of COVID infection in different countries, in different regions, in different ethnic groups inside the same population. At the same time, epidemiologists in today's pandemic situation are identifying causes and offering new approaches how to treat the COVID infection, how to treat the complications, how to treat the side effects of treatment, how to compose the correct and flexible treatment protocol. So, study designs in case of epidemiological studies may be of two types, which are experimental and observational. Observational design, please remember it. This is ABC of epidemiology, that observational studies are multifactorial compared to experimental studies. Among observational studies, we detect ecological studies or correlational studies. cross-sectional studies, case control studies, cohort studies, and longitudinal studies. The description of each subtype of observational studies, which I have just listed, they are forming part of research one. So please go back to your content, open your book. If I'm not mistaken, it's chapter 4. Yes, it's chapter 4, where we have the description of case control studies, cross-sectional studies, surveys, longitudinal studies, and cohort studies. What is the difference? Why is follow-up as phenomena important? And different details of this study. So we should not waste now our time to repeat all what is past. Okay, just to make a short recall, a rapid recall, and remember you. So another group of study designs used by epidemiologists is experimental studies, which are randomized clinical controlled trials, which are intervention trials, and which are interventions in populations or communities. Okay, so these are main designs of epidemiological studies. For epidemiological purpose, a population may be considered by doctor epidemiologists or scientists as groups of observation units, all with measurable or quantifiable characteristics. The observation units may be of different composition. For example, human beings, group of individuals, families, or any other unit that we define and describe that forms material for our research, for our investigation. The types of variables to be measured determine the inference that may be drawn. Samples from the same population provide a number of mean values that are likely to differ from sample to sample. This is logical, right? And it's obvious that all these means represent the true mean for the population, but no one of them is fully correct. So the standard error is the variation of the means of all possible samples. And this is called standard error of the mean, SEM, which is equal to the sample standard deviation divided by the square root of the number of observations. So please remember that in midterms, we shall have only definitions of statistical key concepts, no formulas, okay? Because you don't need them mostly. If later some of you will be more deeply interested in the issue, I can provide you with additional material. But on this stage of your professional development and studies, all you need is to understand the key concept. What is standard deviation? What does it mean? It's the square root of the number of observations. What is standard error of the mean, SEM, etc., etc. Okay. So what are doing epidemiologists and scientists during controlling different epidemiological situations, both complicated more or less? They are measuring disease occurrence, disease association, risk, and implications. Okay? The concept of risk is often used in describing when we want to describe the association between certain factor and probability for later disease or harm. How it harms today and how it will harm in the long run, in the nearest future. Okay? To express a certain factor in terms of a risk factor, the population is divided into two or more groups, such as those who are exposed and those who are not exposed, or by grading of the actual exposure. Okay? So we have healthy individuals, we have affected individuals, and we have the total sum, which we are observing. Epidemiological observations may be classified into three categories. First is disease occurrence. Second is association or effect measurements. And the third is measures of importance or implication. Measures of disease occurrence are used in describing causal relationships and in descriptive analysis of the evolution of disease occurrence or mortality over time. It's clear, right? Effect measures or associations yield the strength of the association between the variables, such as between a disease and the possible cause of it, which was the possible cause of the manifestation of the development and later clinical manifestation of this disease. Okay? So examples of different epidemiological measures may be disease occurrence, and it includes incidence and prevalence, association, which includes relative risk, odds ratio, incidence rate ratio, and regression coefficient. And importance is excess risk and attributable risk. Okay? So, what does it mean, measure of disease occurrence? Incidence, prevalence, and duration. There are several measures for diseases and for their occurrence in the population, of which three estimates are of crucial interest, of principal interest. Number of ill or injured people, for example, during our pandemic situation, how many citizens are affected, the size of population, what percent forms of the whole population, and the duration of the condition, clinical signs and reconvalescence period, and complications or follow-ups. The incidence rates are used to explore why disease and illnesses vary between groups in populations. There should be some logical understanding for this, some logical reasoning. The incidence is defined as the number of new affected individuals in a certain population during a defined period, for example, during last 24 hours. And the incidence rate is the number of new events divided by the total observation during the period. At any time, the proportion of a population ill with a defined disorder gives the prevalence of it. Okay? For example, we have to calculate cases per year, cases per person year, and cases per person day. And we shall have some global understanding of the epidemiological situation in this case. Incidence rates for diseases or deaths can be estimated from cohort studies. That's why I asked you to revise chapter 4 from the same textbook. Follow-up time may be very difficult to estimate due to wide variety of reasons, due to migration of population, due to death of patients, due to another reason for ending observation. Okay? I change my place where I live and I move to another state, or I move to another country, or I move to another region, and you cannot follow up my conditions, my life quality. You cannot assess it because I am not physically near you. Difficulty is overcome by making the time interval a censored variable, that is, a variable which is observed only under the specific condition of the end point being attained. Okay? The subjects which are included in the survey from start to the end have the whole study period as their follow-up time. The sum of these individual follow-up times is the total observation time. So remember the definition of total observation time. I repeat, which is the sum of these individual follow-up times. Okay? So incidence assessment assumes that we know how many people are taken ill in a population, 10%, 15%, 99%. But this sort of information is often lacking, and we may only have access to the number of deaths or to the number of people who die from a particular disorder. This implies that we cannot estimate the incidence rate, but must rely on mortality rates. Mortality rates can be looked upon as incidence rates for deaths. The total for deaths from all causes is usually expressed as the number of deaths per 1,000 people per year. Mortality can be expressed as cause-specific or broken down by age, groups, gender, and occupation, depending on the association studied. Okay? So, just to finish with mortality. Mortality rates are analogous to incidence rates, but the event here is death instead of new cases of disease. And 3 cases of mortality statistics are as follows. For example, death to corona infection, if we take as an example today's situation, death due to corona infection, death of other reasons but with corona infection, and the third type is death of other reasons without corona infection. So we have without, and when the corona infection is the very reason of death. So when we are preparing the death certificate, we have to indicate which variant A, B, or C are determinants of death. What was the main motto? Why patient died? Why it's so necessary to do it? Because if we take today's example, there are some suggestions that high mortality rate in case of Italy was estimated because in death certificates, the distinction between A, B, and C sorts of mortality were not detected. So all patients who died and who were infected with coronavirus, they were listed as death due to corona infection. And it's not correct. It's not correct, as you already know from today's lecture. And logically, it's unacceptable, okay? Because viral infection may or may not stimulate the underlying chronic disease. It means that viral infection is not the very important risk factor for, is not the decisive factor for this, okay? So the total deaths will be equal to these 3 types of type A, type B, and type C. And mortality can be described in 2 ways, based on what we have already mentioned. Either as death rate or as death risk. Death risk means the probability of dying during a certain period. So the way it is expressed depends on what we are actually studying, mortality under A, B, or C. The mortality rate associated with corona infection in our case can refer both to those who die from disorder A or to those with disorder B. It often is absolutely impossible to distinguish between A and B in a sample. Another measure of interest is disease lethality or fatality rate. This is the mortality rate in a group of patients that designates how many die from a certain disorder among those who have the disorder during a certain period of time. So, together with the listed above, very important measures of status of health in a country are infant mortality and perinatal mortality, which are often used as indicators for living conditions, quality of healthcare systems, and mother and child care. So you can easily understand that in countries with low economy, in societies with low or middle income. These variables are very estimated, are very complicated. Okay, mother and child care, health system generally, for example, how public health system works. Okay, what does it mean, infant mortality? Infant mortality is the number of deaths among children under the age of 1 year per 1,000 live births during the same period. Okay, for example, we take as a period of observation 1 year, from January to January. Perinatal mortality is the number of stillborn deaths during the first week after birth per 1,000 born, including stillborn in the same period. Stillbirths are the number of dead babies per 1,000 babies born, including the deaths during the same period. Just to concretize more, the first year of life is usually divided into different periods, and mostly we divide it as first 24 hours, 1 week after the birth, under or first 4 weeks, the period with neonatal death, and 4 weeks to less than 1 year, post-neonatal death. So we are distinguishing these 4 periods in order to classify the death frequency. Okay, and then later to try to explain the very reasons which conditioned this death. Okay, and the basis for these statistics on the causes of death are data entered in death certificates. Okay, and in your textbook, there is an example of Norwegian death certificate, which has 2 parts for the cause of death. Part 1 for the main cause or the underlying disease, and part 2 for the other conditions contributing toward death, but not the direct cause of it. It's very important part of understanding of concrete reasons which contributed to death. Death certificates are handled in different ways in different countries, of course. There may not be unified certificate model. However, the classification of diagnoses has been internationally standardized. Sorry. The origin of the present-day system dates from 1850s, from the middle of the 19th century, and the first edition, the International List of Causes of Death, was adopted by the International Statistical Institute in the end of the 19th century. If I'm not mistaken, it's 1893. The current International Classification of Diseases, ICD, International Classification of Diseases, was adopted by WHO in 1948. The classification system has been revised a number of times, and the current system is edition number 10, 10th edition. So you see, why are we perfecting this classification? In order to be more precise when we are diagnosing the death, when we are diagnosing, but when we are defining the concrete reason of death, we need to know the concrete reasons which conditioned the lethal outcome. That's why we need to know why do we have concrete complications to elaborate better treatment protocol, to decrease as more as possible the side effects of treatment, to synthesize more purified medications with less side effects, or to apply better research design to accumulate more new research data. We are also preparing morbidity registers. These are documents on all submitted individuals, and they are supplied with statistical tabulations of occurrence, frequency, and survival. Morbidity register is very important to study different aspects of population health, of public health, of genetical diseases, of predisposition to diseases. And various disease registers are maintained around the world. The most common are inpatient registers, cancer registers, and birth registers. Registers of infection diseases, because they are very rapidly disseminated, some of which aim at chronic disorders such as tuberculosis. And you know that tuberculosis till today is a very big challenge for developing countries, or countries with low economy. A full description of the registers is beyond the scope of this very nice textbook which you are using for your studies. And also, a full description of the registers are available on the WHO website when you have classification ICDs. So now you understand how important it is to prepare registers, birth registers, death registers, and registers in cases of concrete disease or group of diseases. When we are preparing, when Ministry of Health is preparing in any country, never mind, it does not matter, when the Ministry of Health is preparing the list of medications that should be imported, because not all countries are synthesizing new medications, especially developing countries or countries with middle income. Most of the medications are imported. When we are preparing the list of medications to be imported, we take into consideration the information of registers, the prevalence and the incidence of diseases. For example, if we have very high incidence of epilepsy, we have to import the medications to treat this disease. If we have very high incidence of tuberculosis, we have to import anti-tuberculotic medications. If we have very high incidence of children leukemia or cancers, we have to look in our registers which group of cancers are of high incidence inside the region, inside the country, in our population, and import and implement concrete public health projects to decrease the incidence and to study statistically in dynamics what was the incidence 3 years ago, what we have today, and to predict somehow with more or less precisely to predict what may be our incidence in the nearest future. In case of chronic diseases, it's more or less possible. In case of infection diseases, it's a little bit more complicated. Okay. So principal differences when you will revise the case control studies. Please go back. I ask you once more, go back to chapter 4. But here you have box 9.4. It's on page 255. And there are listed principal differences between case control studies, cross-sectional studies, and cohort studies. So population measures incidence, prevalence, and association. And then you have very concrete description of case control studies, design and structure. When you are defining case control studies as a number of conditions in the two groups to determine how they differ in regard to a number of possible etiological factors, right? When you are detecting the advantages and disadvantages of providing this sort of studies, because main advantage of case control study may be the relative simplicity to carry them out, and that they are cheaper, reasonably rapid, and suited to infrequent conditions. They permit to examine very large numbers of possible risk factors, and they may also be organized in multi-center studies. And the disadvantages. The main disadvantage may be inverse direction of the data on exposure, which is collected after the patient has become a case. Okay, so you have to read about mesh case control studies, about design and structure of cross-sectional studies, because they may differ. The main idea is that cross-sectional study collects all data at one point in time. This permits the prevalence of a condition or variables of interest to be assessed. And the advantages is that these studies are clear and permit a large number of variables to be examined. The methods can be standardized by the researcher, and the clear-cut definitions may be applied to the exposure and endpoints. Concerning disadvantages of cross-sectional studies, we can say that it has no dimension of time, so it cannot support conclusions on the risk of disease or on the inference of causality. One way to circumvent this drawback is to formulate questions that assess an individual's past, such as inquiring about previous lifestyle, occupation, or other exposures. But this enables the researcher to categorize individuals with regard to previous exposure, even if the collection of the information occurred at one point in time. Okay? Cohort studies is one that follows a defined group or cohort, in other words, over a given period. The usual approach is to start with healthy or unaffected individuals. The main purpose is usually to assess the possible effects of various external or as well as internal factors on the risk of disease. Advantage of cohort study should be principal advantage, that it includes the dimension of time, which permits drawing conclusions with regard to causal associations. The studies are intuitively easy to understand. Numerous variables can be assessed at the same time, and one can apply standardized methods with clear definitions with regard to both exposure and endpoints. Both incidence rate and incidence rate ratio can be estimated from cohort studies. Large cohort studies permit more than one type of endpoint to be assessed, whereby multiple disease problems as different exposure variables might be examined. And what about disadvantages of cohort studies? Well, several practical and inferential problems are associated with cohort studies. Disease with a low incidence rate are not amenable to drawing causal conclusions, as too much time is needed to occur a sufficient number of events upon which conclusions may be drawn. Cohort studies are, however, suitable for addressing risk factors that are stable over time and for assessing diseases that are relatively frequent or of certain duration. Cohort studies are relatively costly in contrast to our previous mode of study, type of study, and require long follow-up, as well as an apparatus for follow-up and updating of the database. Another weakness is that the registration of exposure variables can be inflexible. Data on exposure are collected at baseline and then used to construct the different exposure categories. So you see a lot of disadvantages here. A lot of disadvantages. Cohort studies will, as all other epidemiological studies, contain three principal elements. Please remember this. I will ask about this. First is choice of target population, containing the study of population, methods for exposure ascertainment and registration of endpoints or events. Okay? So these are the main sorts of studies which are used by epidemiologists and researchers in this field. So please revise together with this chapter 9, please revise second part of chapter 4. So, few words about effect measure in epidemiological studies. Inside this topic, we need to define relative risk or risk ratio, RR, odds ratio, OR, and incidence rate ratio, IRR. And three divided measures: excess risk, attributable risk, AR, and population attributable risk, PAR. Please revise our abbreviations, they are very helpful. Okay, so we have here formulas which we are not including, just read it several times with examples and tables. Look into the tables because they serve as a very nice possibility to explain the definitions. Okay, what else? Then we will have chapter 9.9, which is experimental studies and randomized controlled trial. So inside this, we shall read that case studies, case control studies, cross-sectional studies, and cohort studies provide valuable insights into the associations between, on the one hand, causal factors and disease risk. We need to understand this. Which are main factors which determined the development and clinical manifestation of disease, and which are main risks. So we need to perform risk assessment, risk estimation, and then risk communication. Here, research is and epidemiology is very closely linked with public health. When you will study your public health, you will see that there is another separate chapter in risk assessment and communication. Risk assessment means we are assessing risks of incidence and prevalence of different diseases in different population groups. Risk communications means we are educating society in order to diminish the development of risks, the development of diseases, the clinical manifestation of diseases. Okay, so that's why we say that risk assessment and communication are two very effective tools for assessing morbidity and for analyzing mortality as well as complications of clinical manifestations of different diseases. So these studies, case studies, case control studies, cross-sectional studies, cohort studies, provide not a big information on effectiveness and efficiency of treatment or intervention. These trials differ from cohort studies in the sense that observers or investigators responsible for the experiment actually control the exposure status. So you see what is the difference between experimental studies and observational studies. Why do we need to pass through all 6 stages when we are synthesizing and testing new medication? We are testing new medication using in vitro system. That means isolation of group of cells, tissues from the organism. When homeostasis does not play a very crucial role when we are isolating it. Then once this is tested positively, then we move to in vivo system. In vivo system means we are injecting the medication in the laboratory animal, in different laboratory animals, white rat, white mice, white frogs, dogs, cats, monkeys, pigs, etc., wide variety of laboratory animals. And when we receive the positive results testing our new medication, for example, some medication is tested now against corona infection, then we move to clinical trials. So what I want to say is that these three main steps, some of them may be skipped in case of pandemic when we need very rapid accumulation of information. That's why we say that trials which are based and which contain very long follow-up, it's a little bit complicated trial in case of pandemic. So some stages may be skipped, and that's why risk communication plays here a very important role. All patients who are enrolled in clinical trials, they should give to researchers their signed acceptance that they are agreed to be enrolled in the clinical trials, because the risk should be communicated to them. The risks why they that they may suffer from from mild to severe side effects of the new medication and of possible complications of treatment. Okay, so this is the main topics which I wanted to cover today. It's a pity that nobody has joined to today's lecture, but as soon as I will disconnect our lecture, it will be automatically recorded and uploaded to your portal. And this is very important chapter, this epidemiology, different sorts of different types of trials, risk management, risk assessment, risk communication, different sort of designs, cohort studies, cross-sectional studies, case studies, longitudinal studies. So please revise them very carefully, because today epidemiological studies are in the very center of the attention of medical society and academia as a whole. So please be attentive. Please don't forget to revise the chapter number 4 from your research 1, because in a more detailed manner the case control study, longitudinal studies, and different sorts of studies with their advantages and disadvantages are described. And please keep all these in mind. The statistical formulas will not be included, only very key definitions, what is standard variable or deviation, or root square, etc., etc. Just read several times, couple of times, formulas in order to understand the definitions. Frequently students ask me, do we need to memorize our examples because our book is rich in examples? No, you don't need to memorize examples, because examples do not form part of your midterm, because examples are placed in your book in order to give you possibility to understand the definition. Okay. So, as we cannot have questions because nobody joined the lecture, thank you for your attention. I hope that our audience will be larger next Saturday, and we shall have some possibilities to change our ideas. Thank you for your attention, and I'm open to your questions. You can either send me your questions by email or right here in the chat. Thank you for attention, and hope to have possibility join you next Saturday. Bye.